My name is Justin Zimmerman. This is my final for the FMT 104 course. It is a project about the efficiency of LED light bulbs. I'm going to go over my construction first. I have 3 switches. It has the power coming in from the power outlet. I have this meter here. I'll talk about it in a minute. The power comes into the first switch. The power feeds all 3 switches. The first switch, the power gets interrupted by the first switch to the first light. The second light gets interrupted by the hot to the second light, and then the third switch interrupts the hot for the third light. And all the neutrals are tied together and all the grounds are tied together. So with that being said, I can turn on the incandescent light, the fluorescent light, and the LED light individually, or all at once, but that's not the point. They're all 40-watt lights. So we're going to look at this meter. It is a P4440 kilowatt meter. It tells me my hertz, my amps, my wattage, my power factor, and my kilowatts an hour. So if we hit the button, we're right now at 117 volts, which is our house power. It's off because it's nominal, so we're not going to get exactly 120. We're going to hit the watts, because that's what we're going to be talking about. I have to turn a light on. So incandescent, we're going to look at incandescent's going to draw 38. So 38.9. This will all be watts. I'm going to try to keep this brief and good. And we're going to turn it off and turn on the fluorescent. And a fluorescent's going to be significantly better, but it's not going to be the greatest at 11.3. And then we're going to turn on the infamous LED, which, drumroll please, is going to be 2.6. Now you can take this and multiply these numbers by about 4 hours is the American standard for how much a normal light is on in a household in a given day. There's usually typically 40 lights in a normal household. So times that by 4, we're not going to go into the math, but then you get that number and then you times that by 365, which gets you how many kilowatt hours in a given day or year. And then the numbers for these individual ones for a year running it, an incandescent will cost you $10. A fluorescent would cost you $3, and an LED would cost you about $1 to run. The difference between this is an incandescent's only going to last you about 3,000 hours. A fluorescent's going to last you about 10,000 hours, and an LED has potential to last up to more than 30,000 hours. So the amount of economic and environmental gain from changing to LEDs is staggering, only just for one light bulb. You could do multiple bulbs in a household, and if everyone just did more than a couple bulbs in each one of our households, we could save a lot of money just by switching a couple bulbs to LEDs. So that's what my project is about, and the efficiency of LEDs and how we should change all of our bulbs to them. Any questions?
Good job. Good job.